All right, in this video, we're going to be working the Unit 12 review. And I'd actually started to record this, but then I accidentally displayed the reduced row echelon form of a couple of matrices that are on the test, and so I had to start over. So part A of number 1, we're going to be solving a system. And this unit, it's all about the graphing calculator, but there are going to be some transformation questions and some inverse questions that are stuff from the last unit that I felt like we didn't quite accomplish well enough on the last unit test. So number 1A, we're going to copy all of the coefficients down into a matrix. Okay, that's the augmented matrix that represents the system. Part B is we're going to write the reduced row echelon form, so we're going to have to reduce the matrix. So I'm going to go into the matrix menu, I'm going to edit matrix A, I'm going to ask for a 3x4, and I'm going to type in my numbers, -6, -2, 2, -8, 3, -2, 4, 8, that was not a 4, 8, 6, -2, -6, and 18. Okay. Got all the numbers in there. Now I'm going to call for reduced row echelon form. So that's in matrix math, RREF on matrix A. Go there. I feel like I must have typed a number in wrong. Okay, let me go and look. I'm not saying just because of the decimals, but we typically expect to see -636, -2, -2, -2, 2, 4, -6, 2, -4, -6. Okay, I wrote it down wrong and then typed it in wrong. And then -8, 8, 18. All right, so then I'm going to ask it to do the same thing. And there we go, that's more like it. Okay, so get it out of the glare. We see 0, 0, 0, 1. And I'm going to just copy down the reduced echelon form, 1, 0, 0, 0, 1, 0, -2/3, 1, 0, and 0, 0, 1. This is saying 0 equals 1 right here, so I'm going to say part C, no solution. Now over here, number 2, we've got a matrix that represents a system. So this is kind of backwards, right? So we're going to start by writing the system, and then we'll transform the matrix to reduced row echelon form to find the solutions to the system. Okay, so the system is going to be 1x, no y, plus 2z's equals 5. 3x minus 1y minus 1z equals -2. And then 6x minus a y plus 5z equals 13. And then I'm going to go in and I'm going to clear the RAM, second plus 7, 1, 2. You don't have to do that, but I think it's safer than trying to overwrite a matrix. So I'm going to ask for a 3x4. I'm going to type in those numbers, 1, 0, 2, 5, 3, -1, -1, -2, and then 6, -1, 5, and 13. Okay, so then I'll ask for RREF of A, and then I've got myself infinitely many solutions. Okay, I can see that because I've got that row of all zeros. So to B, okay, I'm going to kind of copy these down into new equations. X plus 2z equals 5. And y plus 7z equals 17. Okay, z can be whatever it wants. So I'm going to solve for x and y in terms of z. X equals -2z plus 5. Y equals -7z plus 17. And z can be whatever it wants. Z equals z. Okay, now, let's see. Are there any other systems here? There's going to be one with the quadratic. But, on its own, I don't see any that come back with a unique solution. So we need to be ready for that as well. And, but you got plenty of examples on that on the homework, notes, quiz, that stuff. So, if you are not remembering what that looks like, you need to go back and look. Okay. Now, a dog opens a savings account at the local bank, depositing $14 at 8.15% interest. The local bank pays interest once every 3 months, which would be quarterly. That's once per year. Or four times per year, not once per year. So I'm going to start by writing a formula for the value of the account after t years. Okay, I'm going to say, all right, v of t, it's p times 1 plus r over n to the nt. And you are given that formula on the test. And you're working the review, you're free to go back and look that formula up off the notes book. So the principal is the starting amount, the $14. 1 plus the interest rate, 0.0815, divided by n, where n is the number of times per year interest is added. That's 4 times per year if it's once every 3 months, to the 4t. And that's my formula for v of t. What will be the value of the account 5 years after it's opened? That's v of t equals 5. So that's v of 5 is 14 times 1 plus 0.0815 over 4 to the 4 times 5 is going to be 20. And that's going to be something we need to use the calculator for, because I don't know how to take that number to the 20th power. So I'm going to go over here and I'm going to say 14 times 1 plus, use the fraction bar if you've got it available, 0.0815 divided by 4 to the power of 4 times 5 is 20. And I get $20.96. Okay, how many years until the value of the account has tripled? Okay, so that would be like finding the t that gives me v of t equals 14 times 3 is 42. Okay, so I need to find out where is v of t equal to 42. So I'm going to use the calculator for that. And y1, I'm going to plug in v of t, 14 times 1 plus 0.0815 divided by 4 to the power of 4t. Okay, and then I'm going to see where this equals 42. But if I'm going to try to intersect them, I know that I'm going to need to be able to see y equals 42, so I need to adjust the window. I think I'm going to let the, x, maybe I'll let x run 0 to 20. And then the y minimum, I'm going to let be 0, and the y max be 50, so that I can see this 42. It's graphing pretty slowly. Kind of wish it would graph a little faster. So I've got a class about to come in, but okay, maybe this one will go faster. Where's 42? There we go. That's a little faster. All right, so we're going to see where these two things intersect. So I'm going to calculate the intersection between blue and red, and that'll give me t equals 13.617 in years. How many years? Round to 3 decimal places. Good. Okay, find the value of v of 100 and interpret its meaning in the context of the problem. All right, so 3D, v of 100, okay, we're just going to find the value of v with t equals 100 plugged in, and we can do that. You know, we've got v of t plugged into y1. So I'm just going to plug in on y1, so I'm going to ask for y1 out of f4. y1 of 100, just like v of 100, is going to be, yes, $44,673.69. Okay, and that's the value of the account after 100 years. Which is going to show you that 8% is a very good interest rate. All right, so 3E is find the value of V inverse of 100. Okay, when we're confronted with an inverse, we set the function equal to that value. Okay, and that should, give you a hint, because we already did one like this. We found the number of years it took to get to $42. V inverse of t is the number of years it's going to take to get to $100. And so I'm going to say, all right, I probably just need to be, instead of 42, finding where this thing equals 100. And I'm going to see if this helps at all. Maybe this will cause it to graph faster. No, it's not going to graph any faster at all. But what I'm going to do is I'm going to just, move on to 3F and wait for it to graph. Okay, the graph of g of t is formed by horizontally stretching the graph of v by a factor of 5 and reflecting it across the x-axis. Okay, so g of t equals, if I'm in a horizontal stretch by a factor of 5, I need to replace t with 1/5 of t. So I'm going to say that's v of 1/5 t. And then reflection across the x-axis is where we are going to, I'll even draw you a picture. Right, we're going to make y negative. Y became negative. So the v is the y coordinate. We're going to multiply on the outside by -1. Okay, that would be a suitable place for you to stop in my class. I don't have a problem with you, writing it in terms of the formula for v. But if we wanted to be, giving an explicit formula, so we'd say it's the negative of v with t replaced with 1/5 t. So I'm going to take this, just negative 14, and then 4 times 1/5 t. Okay, if we had to write an explicit formula, that's how we would do that. Okay, I have got, oh boy. Okay, I'm going to have to come back to this one again a little bit later because I didn't give myself enough x, right? We know it's going to curve up and hit, but it's going to be after this t value. So I need to give myself more x's. So I'm going to go 0 to 40, and then I'm going to give myself a little more y too. I'm going to go to 120, and then it's going to take forever to graph, but you know, it's going to go and all right, so I think I'll set up the next one, number 4, part A. The half-life of a rare element is 3.1 seconds. And we've got an alien doing an experiment on the element, obtaining a 175-gram sample of the rare element at t equals 0 seconds. And what you're going to see is it's not going to last for long. Okay, I've got my, didn't take as long as I thought. We're going to find where blue and red intersect, and that's going to be 24.369 years. Okay. So t equals 24.369 years. Okay, so I would say, you know, v inverse of 100 is the time it takes for the value to reach $100. So for A, I have a feeling it's going to start off, write me a formula for the mass of the sample yet. Okay, so the mass of the sample, m of t, we use the half-life formula, so m of t equals the starting amount, which is 175 grams, times 1/2 to the t over h, and h is the half-life. So they said the half-life was 3.1 seconds, so t will also need to be measured in seconds. How much of the sample will be left after 5 seconds? Okay, so that would be m with 5 plugged in. That would be 175 times 1/2 to the 5 over 3.1, and we'll figure out what that equals using a calculator. Okay, I might, you know, be well served to type this into y1. 175 times 1/2 to the power of t divided by 3.1. Okay, and then what I'm going to do is I'm going to ask for y1 and have it plug in t equals 5. Okay, now you could have typed it in just the same way. Either way, you're going to get 57.214 grams. So after just 5 seconds, we have, you know, not that much left. For C, the alien will no longer be able to run its experiment when the mass of the sample goes below 0.1 grams. How many seconds will the experiment last? Okay, so I need to see when does m equals 0.1. So what I'm going to do is I'm going to graph y, I'm going to graph 0.1, and I'm going to see where they intersect each other. And so I'm going to zoom to the standard window and just see if this works. You know, I would like for it to just work on the standard window. That would be ideal, but somehow, Okay, now it's graphing 0.1. So this is not working. It did not catch the exponential decay curve. So what I'm going to need to do, I'm going to let y run from -1 to, I don't know, I don't need too much in the y. I mean, I might just leave -1 to 10. But x, I'm going to let go from 0 to 50 with a step the size of 5. And maybe this will, there we go. Yeah, so it really is decaying pretty aggressively. And it looks like it went below 0, but it doesn't, don't worry. We're going to calculate the intersection between blue and red, and that's going to be t equals 33.397. And so that's how long the experiment lasts, right? Because at t equals 33.397, the mass hits 0.1. After that, it goes below 0.1, so the experiment will be over. All right, and then for D, find the value of m of 10. That's going to be the mass after 10 seconds. And then for E is going to be m inverse of 10. And I'm going to give the meanings of those first, and then I'll solve for them. So m inverse of 10 is the number of seconds it takes for the mass to equal 10, right? And we do m inverse of 10, we solve the equation m of t equals 10. So it's time until mass is 10 grams. And so I'm going to find those first by, I think I've got it over here so I can calculate a value. So I am assuming I have that. Okay, yeah, when t equals 10, blue curve is at 18.706. And then m inverse of 10, I'm going to have to do another intersection. Okay, but it shouldn't take too long. Yeah, right, because this one graphed pretty nicely the first time, and it's doing its graphing thing. And then, okay, well, we'll find out if it's at the edge of the window, like, is it actually going to be able to find the intersection? Blue, red, give it a guess. Yes, okay, it did work. I did not need to change the window. So that's m inverse of 10 is 12.801 seconds. And then f is going to be a transform problem. So f of t is 2 times m of t plus 3. Describe the transformations of the graph of m that would give the graph of f. Okay, replacing t with t plus 3. That's a shift left by 3. Okay, and then multiplying by 2 on the outside is going to be a vertical stretch. And those vertical transforms, they work exactly the way we expect. So multiplying by 2 will make it 2 times as big. So vertical stretch by a factor of 2. Okay, and that's, you couldn't see it, but there you go. That's number 4. Okay, and I can hear I've got people at my door. They are ready for class. I'm going to pick this up after class. Okay, so now number 5 is a golfer hitting a ball off of a platform at time t equals 0. The approximate heights of the ball at various times are given in the table. So we are going to do quadratic regression, yeah, right? Because we know that when we see projectile motion, that's probably a sign we're going to be doing quadratic regression in this class at least. So I'm going to clear the RAM, go into the stat menu, because that's how we enter the lists. We're going to edit the lists, and we're going to type in these heights in the x column, 0.7, 1.6, 2.3, 4.4, 5.1. And then we'll type in list 2, the corresponding y values. Well, okay, I see. Oh, whoops. Okay, this is labeled backwards. Okay, I didn't notice this until just now. This is not going to make sense for height versus time. Maybe if we were on on the moon or something with very low gravity, maybe that would make sense. But even still, I think that would be ridiculous. So I'm still going to say this is time. Okay, ask for your forgiveness. And this is going to be height in feet and time in seconds. Okay. 67, 112, 128, 84, and 38. Okay. And then we're going to run quadratic regression on this. So we're going to go back to the stat menu. We're going to calculate a quadratic regression. X list, Y list. We're going to store the regression equation in Y1 to save ourselves a little bit of time. And then we're going to calculate. Done. Okay. And then now I've got this. So I guess that was glares. Horrible. All right. So 5. H of t is negative 16.009 t squared plus 86.212 t plus 14.645. Okay. And that's a formula for the height of the golf ball at time t. Height was the golf ball launched from, like basically how high is the platform. And so, if it's launched from the platform at time t equals 0, we're just going to find h of 0. So we're going to find the height of the golf ball at time t equals 0. And according to this regression equation, it's going to be, 0 plus 0 plus 14.645. So that'd be 14.645 feet. This is my And my reason is that it's, the height at time 0. That would be plenty. How long is the ball in the air? Give a reason for your answer. Well, I think then we would need to know what time it hit the ground. So we need to find what t gives me h of t equals 0. I need to find h inverse of 0. So I'm going to go, but I'm going to use the graph for this. So I'm going to zoom to the standard window and just hope for the best. Okay, there's the ball going up, and then here it came down, and so I'm going to calculate the 0. And so this is height versus time. Looks like it's between 4 and 7. It's going to be 5.550 seconds. A5D says 10 seconds after the golfer hits the ball, another golfer hits a ball. The height of the second golf ball is modeled by B of t. Graph of B is formed by shifting the graph of H right 10 units and then vertically stretching by a factor of 2/3. Write a formula for B of t. Oh, okay, this is the one that worked in class today. So this one, because H of t has got a lot of numbers in it, I think this one especially would be all right to say, all right, B of t is something I get by manipulating H. Okay, so if I shift H right 10 units, what had been h of t will now be h of t minus 10. And vertical stretch by a factor of 2/3, I got to multiply on the outside by 2/3. So I really think, this would be a safe place to stop in my class, right? We could just stop here. This is a formula for B of t, doing the things to h of t that you need to do. Right by 10, multiply by 2/3 for vertical stretch. But if you felt like you had to get an explicit formula in terms of h, what you would do is you would multiply 2/3 on negative 16,009 t minus 10 squared plus 86.212 times t minus 10 plus 14,645. And then that would be an explicit formula in terms of t. Do not go square that binomial and distribute all these numbers and collect like terms. That's not going to be any better of a formula. Okay, this is clearly something we're going to have to work with using a calculator anyway, so might as well just leave it out there. Okay, and that's going to be a formula for B of t, either this or that, but I would recommend sticking with that. Okay, number 6. Suppose g is a quadratic function. Values of g are given in the table below. Okay, so this could be where I give you a table. I could give you a graph with 3 points on it. I could also just give you the points listed out, like g of -1 equals 10, g of 3 equals 14, and g of 6 equals 59. Okay, I could give you this information for this question a variety of ways. Okay. But if we're going to do quadratic regression to find a formula for g, I'm going to bring in the calculator for that. So I'm going to go back to the stat menu, but if I'm going to, be editing the lists, I should just clear the RAM probably. Okay. We've got the RAM clear. We're going to go to the stat menu. We're going to edit the lists. -1, 3, and 6. 10, 14, and 59. And there's only one parabola that goes through these 3 given points, so, and hopefully if I, did it right, then it'll be like pretty nice numbers. So we're going to calculate a quadratic regression. I don't think I need to store this regression equation at all. Yeah, 2, -3, 5, those are good numbers, right? So you can tell that's what I was going for. So I've got 6 is g of x equals, it was 2, -3, 5. So what I'm looking for is, what I have is a is 2, b is -3, c is 5 on ax squared plus bx plus c. So 2x squared -3x plus 5. That's probably the easiest way, given 3 points, with the calculator to find the equation of the parabola that goes through them. But there's another way that we've done in this class already, and I just wanted to bring that back so that you were reminded of, where we've been and where we're heading. Okay, we can set up a system and solve this, right? We're going for y equals ax squared plus bx plus c. So what I'm going to do is I'm going to take each of these points and I'm going to turn them into like an equation, where a, b, and c are the unknowns. So -1 and 10 that's going to give me, okay, y equals 10 when x is negative 1. If I square negative 1, I get positive 1. So 1a. B is going to be b times negative 1, so negative 1b. And then plus 1c. Then for the second point, I've got 3 and 14. So x is 3, y is 14. 14 equals 3 squared a plus 3b plus c, which I might call 1c. Because I'm going to be turning this into a matrix, finding the reduced row echelon form of that matrix, and, going about it that way. And this is an option you have, but, on the test, it's just going to be like, hey, here's 3 points, find the parabola that goes through them, and you're going to have to decide which way is better for you. I think the better way for everyone is going to be quadratic regression, but, you can do whatever you want. So 59 equals a times 6 squared, so 36a, plus b times x would be 6b, plus c. And I'm going to turn this into a matrix. So I've got 1, 9, 36, negative 1, 3, 6, 1, 1, 1, augmented with 10, 14, 59. And then we're going to have the calculator do the reduction for us. So, I think this, I haven't done that in this video. I'm just going to go straight for it. I'm going to, if you have one of the color editions, you can do this. We're going to call for a matrix out of F3, ask for a 3 by 4, and then just type in the numbers here. 1, negative 1, 1, 10, 9, 3, 1, 14, 36, 6, 1, 59. Okay, and then we should expect to get the same numbers back to negative 3 and 5 that we got the other time. Okay, and then sure enough, we've got a unique solution to negative 3 and 5. And the unknowns we have here are a, b, and c on this ax squared plus bx plus c type equation. So I'm saying again, y equals 2x squared minus 3x plus 5. I think the quadratic regression was a lot faster and a lot easier, but it's up to you. You can solve these problems however you want, as long as it's correct and mathematically justified, like we always say. So I did A and B, find the minimum value of G. That's something we should definitely do with a calculator, right? Because to do it without a calculator requires calculus, and we don't know how to do that because this is just an algebra class. So we're going to find the minimum value of G by going to y equals, plugging it in, 2x squared minus 3x plus 5. And then I'm just going to zoom to the standard window and hope for the best. Okay, the minimum value is going to be at the vertex of the parabola, but we can use calculate to find that minimum. Yeah, there we go. So I'm going to calculate a minimum. It's to the right of 0 and to the left of that point. We can give it a guess. But then it gives us, okay, the minimum happens at x equals 3/4. That does mean 3/4. Just got a little bit of round off error. And y is 3.875. And if we're looking to the minimum value of g, g is the output, the y coordinate. So the minimum value of g is 3.875. We obtain that using the calculator. So 6D is going to be find the x-intercepts on the graph of G. Oh, what a shame. They don't exist, right? It would need to be a downward facing parabola with this location of vertex. So I'm going to say there are no x-intercepts. Okay. If there were, we would have calculated 0, kind of like we did up here to figure out how long the ball's in the air. This must be something I asked you for on the test, and I bet there are x-intercepts and a minimum somehow, or a maximum in x-intercepts. All right, so that's going to be enough of that. All right, number 7, consider the piecewise function below, and a is going to be a constant. This is one that I definitely took from AP Classroom for AP Calculus. But this is a problem that is right at your level, solving an equation using a calculator. So find the value of a that makes f continuous at x equals 3. What we need for this piecewise function to be continuous is for the two pieces to be equal to each other at x equals 3. So I'm going to say x squared minus a needs to be equal to the square root of x plus a at the point where x equals 3. And then I plug in there, and I get 3 squared is 9 minus a equals the square root of x equals 3 plus a. And now, we probably could solve this by hand if we really, really had to by squaring both sides, but we don't want to do that. Right? Oh, wait, it was the cube root. Okay, now we really don't want to do that, right? Because we don't want to take 9 minus a to the third power by hand. That's just going to be way too much. We're going to use the calculator to solve this equation. So, with the techniques that we've used in this class, I think the most obvious thing to do is going to be graph 9 minus a and y1 and the cube root of 3 plus a and y2 and find where they intersect each other. Okay, now we are going to have to use 9 minus x and the cube root, which we find in math down here, cube root of 3 plus a, because the calculator wants to graph with x being the variable. But if we graph this thing on the standard window, we're going to be able to see an intersection, I hope. Okay, yeah. There it is. All right. So we're going to calculate an intersection between blue and red, and that's going to be at x equals 6.856. Okay. But 6.856 is the value of x that makes these two things equal to each other. So I already lost track of the number. Calculate an intersection between blue and red. 6.856. Right, the value of a that makes these two things equal is going to be the same as the value of x that makes these two y's equal, and that's the principle we're using when we use intersect to solve an equation using the calculator. And like next year, year after, like moving forward, this is generally how you're going to want to solve an equation with the calculator. Also, I just got the tutorial on how to use the equation solver on the TI-84, and this is something I've had trouble with in the past, but I just want to show you this in option. Just cleared out the RAM so I can show you all the steps. So we're going to go to Math, we're going to scroll up and do Solver. And equation 1, we're just going to do 9 minus a. So 9 minus x. And then in equation 2, we're going to say cube root, which we get out of Math, of 3 plus x. And then we're going to press OK. And then it says x equals 0, and it's like, that's not what I wanted. But then you press solve, which is, alpha down here, it's alpha and enter. And then there we go. X equals 6.856, like we had before. Now, you can also, if there's more than one solution, evidently you can go and kind of manipulate the bounds that it's looking at. This one only had one solution, but I just wanted to show you the equation solver because it's something I've known has been on the calculator for a long time. I just didn't really know how to use it. It seemed really easy. I'm not sure what my problem was before, but this, this function isn't on a TI-83 or all types of TI-84, and the graphing technique does always work. So I'm definitely endorsing the graphing technique, but also just showing you the equation solver. I'm sure all of us are no more than just a short YouTube video away from understanding how the equation solver works, but I just have never actually put in the time to do it. So, oh, and then there's another part. Whoops. So part B, if g of x equals f of negative x plus 4, describe the transformations of the graph of f that would produce the graph of g. Is my pen back there? Yes, it is. Oh, well. It's 7b is going to be, all right, f of negative x. If I replace x with negative x, that's going to be a reflection across the y-axis. That was the first transform. And then the second transform is going to be that plus 4 on the outside. So if I'm adding and subtracting, that's a shift. If I'm doing it on the outside, it's vertical, and plus 4 on the outside is going to be a vertical shift up by 4. And that's going to be 7b. Now, number 8, consider the table of values for the continuous function f. All right, if f is quadratic, what's the value of a? And if f is exponential, what's the value of a? So 1, 5, 9, 13. So for part A, if f is quadratic, then we're looking for a constant second difference. So the first difference is, well, 48 minus 72. That's a decrease, I think, by 24. Can't be too sure, and you're allowed a calculator here, so let's say that's a decrease of 24. 32 to 48 is 16. I know that, so that's minus 16. Second difference here is plus 8. So I need to be seeing a constant second difference, so I need to see that plus 8 here. So I'd say the first difference would be negative 16 plus 8 is negative 8. And to go from 32 to the next one, I would be subtracting 8. So for 8a, my answer is going to be a equals 32 minus 8 is 24. Right. Now, if we're looking at making this an exponential function, well, I'm going to need to see a constant ratio between the terms. So I think to myself, what do I multiply 72 by to get 48? And if you're like me, you don't really have anything in mind. So we say 48 divided by 72, and we get something that you're going to either recognize as 2/3, or you're going to need to go to math, give me a fraction, and then recognize that's 2/3. So I'm multiplying by 2/3. Probably would be good for me to multiply 48 times 2/3, get 32. Okay, so I've verified it's times 2/3 each time. So to get from 32 to the next one, I'm also going to multiply by 2/3. So multiply by 2, divide by 3, that's going to be 64 over 3. Okay, now if you want to do 32 times 2/3, you could do that. I guess you could give me a decimal number, that'd be okay, but you could also do that with a calculator if you wanted. All right, that's gonna be all for this one. This is very representative of what you're gonna see on the test, but if you feel like you need more, you should go back to the quizzes. You should go back to the homework, you should go back to the notes book. But yeah, that's all for this one. Thanks for watching.